Hey guys, today we're going to do the pressure drop and pipe slide using the Hampton. When fluid flows through a pipe, frictional losses occur between the pipe, the walls of the pipe, and the fluid itself, and this causes a pressure drop, which is what you're going to be measuring in the lab today. Now to start, let's look at what each valve does on this pipe. The most common type of valve you'll see in the Hampton is the ball valve, which is represented by this yellow handle. When the yellow handle is parallel to the pipes, that means the ball valve is open and fluid flows through the pipes. However, when the yellow handle is perpendicular to the pipes, that means the ball valve is closed and there's no flow through the pipe. Another common valve on the Hampton is the gate valve, which is represented by this blue knob. Right now, the gate valve is closed, but if I turn it left, then I'll begin to open the gate valve. Now the gate valve works the same way as the ball valve. When it's all the way open, fluid flows through. When it's closed, fluid doesn't flow through. Once I get it all the way open by turning it left, it'll lock, and I'll turn it back half a turn to the right. That way nobody confuses it as being closed when it's actually open to avoid it breaking. Now let's look at how the fluid flows through these pipes. The fluid's going to start in this tank. It's going to travel through the bottom of the tank, through this pipe, and it's going to reach a fork. However, because this valve is closed, it's going to continue to flow through the open valve. It's going to travel back around to a mechanical pump, and it's going to come out of the back of the mechanical pump to this point right here. Notice that this valve is closed, so the fluid is going to travel through the bottom pipe. Once it travels to the other side of the bottom pipe, you notice there's an open valve, so it's going to continue to flow up through another open valve and yet another open valve, and that's going to continue to go all the way to the top, and then the fluid is going to travel all the way back. Now let's look at what happens if we want the fluid to only flow through the third pipe. If you want to change the pipe that the fluid flows through, first open the valves you want them to flow through, and then second close the valves that you don't want the fluid to flow through. This will help prevent any backups of the fluid. So if we want the fluid to only flow through the third pipe, let's open up this valve and open up this valve. So now as you can see it's traveling to the third pipe, but not traveling to the fourth pipe because it's still closed. It's traveling across. This valve is closed, but once we open it, the fluid can flow through and out. So the fluid is now flowing through the third pipe. However, it's also flowing through the first and second pipe as well. To help fix this problem, we're going to close these two valves at the end here. That way, the fluid stops flowing through the first and second valve and is only flowing through this third valve.
So now that we know where the fluid is moving and how we can control it, we're going to turn on the Hampton. Just flip this switch up. So this is a rotometer. It allows us to read our total flow rate. Now, right now, the rotometer reads that it's about 14 gallons per minute. The way you read this is you look at the top of the float and read it with the corresponding number on the rotometer. Now to change this flow rate, you use this globe valve using the right-hand rule. So, turn right to close, turn left to open. When you open it, you increase your total flow rate. And when you close it, you decrease your total flow rate.
Now that we have the maximum flow rate through all of these pipes, we're going to measure the pressure drop at each of the different points. There are 4 pipes located throughout the Hampton. The smallest pipe having an internal diameter of 0.43 inches. The largest pipe having an internal diameter of 1.025 inches. Along each of the pipes there are 3 ports to measure your pressure drop. From port 1 to 2 is 2 feet. From port 2 to 3 is 2 feet. So therefore from port 1 to 3 is 4 feet.
To help you understand how the pressure gauges work, we'll take you through the connections between the pressure taps and the pressure gauges. There are many wires in this picture, but we only need to concern ourselves with 3 of them. We will now highlight the first pressure tap. Out of the first pressure tap is a blue wire, and if we follow that blue wire, it leads us all the way to the first pressure gauge. Now that we've shown you the first pressure gauge, let's look at the second pressure tap highlighted now. Coming out of the second pressure tap is a red wire, which connects itself to a blue wire, and a blue wire leads up to the second pressure gauge. Last of all is a yellow thermostat located on the bottom right-hand portion of your screen. Out of the yellow thermostat is a yellow wire which connects itself to the Hampton. It takes the temperature of the fluid right after the 4 horizontal pipes and right before the 90-degree elbow located beneath the 2 pressure gauges.
Now there's actually time to measure your pressure drop throughout the pipes. You're going to have 2 probes. Take note of which color is in which port. Make sure they're both clamped into position, and once they are, then it's time to read from the pressure gauges on the right.
To read the pressure gauges, notice that the blue probe corresponds to one pressure gauge and the red probe corresponds to the other pressure gauge. And all you're going to do is read whatever pressure is measured on each pressure gauge corresponding to the point on the pipe.
Once that data has been recorded, it is now time to switch the probes. And once these are switched, now it's time to read the pressure once again. Once that measurement has been taken, it is time to switch this into the middle one and take note of what that pressure drop is. And then once you have done it for one pipe, it is time to do the same process for pipes 2, 3, and 4.
Now that we understand how everything works, let's do a trial run to make sure we truly understand this whole process. First, Harry's going to set a flow rate on the rotometer.
It's about 14 gallons per minute.
Now that we know the flow rate, we want the fluid to only flow through the first pipe. So first, like we said before, we need to make sure that all the valves that need to be open are open. So let's check. Open, open. All the valves are open. Now let's close the valves where we don't want the fluid to travel. Once all those valves are closed, we can measure the pressure in the bottom pipe.
So now that it's time to measure the pressure drop in pipes, you make sure that the probes are plugged into 1 and 2 and measure your pressure drop from the gauges.
So as you can see, probe 1 has a pressure of about a little over 15 psi, and probe 2 has a pressure of about a little under 13 psi. And this difference in pressures is the pressure drop.
And now you're going to take the probe from port 2 to port 3 and remeasure your pressure drop.
As you can see, the pressure in 1 is the same, which it should be, but the pressure in 3 is less than the pressure in 2, seeing that there's a greater pressure drop.
And finally, it's time to take the probe from port 1 and put it in port 2. And now you remeasure your final pressure gauge.
This is the pressure for the probe at point 2, and this is the pressure for the probe at point 3, and notice that there's still a pressure drop. Hopefully this video helped you understand how the Hampton works, and now you can do the pressure drop in pipe slab.